Module 6 of the Chemical Technology course, which is dealing with the petroleum refining process. In the lecture 6, we discussed about the catalytic reforming process, which is one of the very important unit of the any refinery, that is for the improvement of the octane number of the low octane naphtha. Some of the other processes that has been developed and that is being used in the refineries to improve the octane number of the some of the feed, low octane feeds to high octane gasoline. So, among these processes, alkylation, isomerization and polymerization, especially the oligomerization, that is very important part in case of the refinery operation. Coverage of the lecture, that will be the introduction, alkylation process, development of the alkylation catalyst, comparison of the alkylation technology with modern sulfuric acid and hydrofluoric acid, common alkylation processes. Then the isomerization, that will have the again introduction, isomerization catalyst, once through process, isomerization of the light naphtha, EOP isomerization technologies, and then the polymerization, some of the technology which are available in case of the polymerization or oligomerization, which I told you, for improving the octane number. Alkylation, isomerization and polymerization have received considerable interest and can be used across wide spectrum of application in refining and the petrochemical production for production of the high octane gasoline, feedstock for the alkylation, petrochemical feedstock, just like the isobutylene or linear alkyl benzene, where also we are using the alkylation process. This is the how the alkylation I will be discussing in detail, what are the feed and other thing, alkylation, isomerization. Let us discuss for the alkylation. This is the petroleum gas, olefin isobutane, distillation, cracking, source, and then the process, unification, type of the product high octane gasoline, application gasoline pool. Similarly, the isomerization, feedstock N-butane, normal pentane, normal hexane, source from the various refinery processes. Process rearrangement, typical product yield, that will be the isobutylene, isopentane, isohexane, and the application, that will be alkylation of the gasoline, that will go to the gasoline pool. Polymerization, light olefins, that will be the C2, C3, C4, various refinery processes, because this process that has become important with the coming of the more and more FCC and generation of more light olefins, and that light olefins that can be used in these processes for upgradation of the octane number. So, the unification process, typical product high octane naphtha, petrochemical feed, and application is the gasoline pool. Now, let us discuss about the alkylation. Alkylation is important unit in the refinery to upgrade light olefins and isobutane into highly value gasoline component. Light olefins are produced mainly by catalytic crackings, which we are getting from the FCC gases, which we are recovering now, and now there has been lot of emphasis in the refinery to separate the various useful component of the C4, because C3 propylene we are recovering, but now there has been continuous interest in the refinery to recover the C4 components of the FCC gases. Alkylate is one of the best gasoline blend because of the high octane number. So, in future refinery, what we will see, because we cannot totally depend upon the either crude oil distillation or the only the catalytic cracking or the catalytic reforming process, but that will be the blend, because the gasoline pool will be getting a blend of the various uh, high octane gasoline which we are getting from the various conversion process. So, reformatted gasoline blend of the product from alkylation, isomerization, catalytic reforming, FCC and hydrocracker, polymerization and plus addition of the oxygenate. So, that will be the reformatted gasoline in the future, because the here also oxygenate means addition of the methanol or addition of the alcohol. So, that will increase the total increase in the output of the refinery and at the same time better octane number. So, alkylation process which was commercialized in 1938, since then there has been tremendous growth in the process. In US and Europe, about alkylate is 11 to 12%, that is going to the gasoline pool, and 6% in the 11 to 12 in the US and 6% in the European country, but still in India we do not have the alkylation process in most of the refinery. I think the new refinery in Bathinda that might have the alkylation in it. One of the major constant in the alkylation process, in the adaptability of the alkylation, because we will be discussing about the catalysts, what are the catalysts that we are using, and the development of the change in the catalyst, use of the sulfuric acid to hydrofluoric acid, hydrofluoric to solid acid. These are the some of the development that has taken place in case of the alkylation, and in the future alkylation process that is going to play very important role in increasing the octane number and at the same time enhancing the production of the gasoline. Alkylate is a key component in the reformulated gasoline. Alkylation process are becoming important due to growing demand for high octane gasoline and requirement of the low reed vapor pressure, low sulfur and the low toxicity. Alkylate is an ideal blend stock to meet these requirements. The process of alkylation, different isoparaffins using olefins were developed during the 30s using aluminum chloride catalyst. However, the catalyst was later replaced by sulfuric acid and hydrofluoric acid. First it was the hydrofluoric, and because of some problem which we will be discussing about the when we will compare these catalysts, sulfuric acid to hydrofluoric acid, and again because in case of the hydrofluoric acid lot of the corrosion problem was there. So, now the shift in the catalyst from HF to solid acid catalyst, that is there. Alkylation of the C5 cut from the FCC can significantly reduce the RVP of the finished gasoline pool. The process of hydrofluoric alkylation, because that was the earlier alkylation process that was being used and still that is being used in many refineries. The process of hydrofluoric acid HF alkylation produces high octane blend stock for isoparaffin, mainly isobutane and olefin, propylene, butylene and amylene to meet all the criteria of the reformulated gasoline. Replacing high risk toxic liquid acids such as hydrofluoric acid and sulfuric acid with solid acid catalyst was the challenging goal in isoparaffin alkylation technology, and this has the major development in case of the catalyst, the shifting from sulfuric acid to hydrofluoric acid and from hydrofluoric acid to solid acid catalyst. So, alkylation, why we are going for alkylation is environmentally safer routes to maximize C5-7 alkanes from C3, C4 olefin and isobutane feed for reformulated gasoline blend stock. Development of the non-hazardous solid acid catalyst is the driving force for more environmentally safe alkylation units all over the world, and now this slowly mills are shifting from the they are changing, they are going for the solid acid catalyst alkylation process. Butylenes alkylation is one of the most commonly used process. However, alkylation of the amylines, because the C5 cut, as I told you, now the more and more interest is for the recovery of the C4 and C5 gases from the refinery, because C4 what we are doing in some of the refinery, MTB, isobutylene, that is going, they are using for making the MTB, methyl tertiary butyl ether, which is being used as oxygenate, but as I told you earlier also, now there is a ban on the use of the MTB in many of the developed countries. So, now what they have shifted to the theme, but alkylation of the amylines obtained from the C5 fraction of FCC can another route to increase the ability of the alkylate, because C5 fraction still we are not doing the alkylation, that is going to the stem manufacture. C5 alkylate amylene alkylation has two-fold advantage. It increases the volume of the alkylate available while decreasing the reed vapor pressure and olefinic content of the gasoline blend stocks. The reaction involved in the alkylation consists of conversion of the isobutane and isobutylenes to isooctane using HF catalyst or solid acid catalyst, whatever the catalyst that you are using. The side reaction which are taking place, that results in increased isobutane consumption, increased acid consumption, increased acid soluble formation hydrocarbons, equipment handling and corrosion problem. The key factors to be controlled in alkylation process are maintaining proper composition of the reaction mixture, which include isobutane and olefins and the HF acid. Maintaining the proper reaction environment, which includes the adequate contacting, control temperature, freedom from sour gases. Making a proper separation of the reactor effluent into various components. This is the reaction which is taking place in case of the isoparaffin alkylation. So, these are the, this is the desired reaction, and this is the, because the your paraffins and the olefin that you are getting alkylation. So, these are the some of the undesirable part that is taking place in case of the alkylation process. Some of the other side reaction is the formation of the paraffins, which boils above and below the desired product, impurities in the feed acid and normal operating particles, all can contribute to the additional side reactions. So, let us discuss now the, because as it shows the number of the alkylation process that has been developed depending upon the catalyst that is being used. The ConocoPhillips process, that is the alkylation of the propylene, butylenes, pentenes and isobutane to high quality motor fuel using hydrofluoric acid catalyst. UOP alkylinium, UOP alkylene process based on the solid acid catalyst for alkylation of the light olefins, because this is the same while discussing the LAB we discussed the solid acid catalyst. Now, the alkylation process for the LAB manufacture is based on the solid acid catalyst. Similarly, in case of the refinery also, the future refinery that is not going to use the HF, but they are going to use solid acid catalyst for alkylation. So, this is the development of the catalyst that has been developed by the UOP. So, the process of the UOP alkylene TM, they use the solid acid catalyst for alkylation of the light olefins and isobutane to form a complex mixture of isoalkanes, which are highly branched trimethyl pentenes that have high oxygen blend values of the approximately 100. So, this is what our interest is, to have highly branched paraffins. UP earlier the process of HF was also there. So, UP HF process alkylation of the isobutane with a light olefins, propylene, butylenes and amylines to produce branch chain paraffin using hydrofluoric acid catalyst. That was the more than 100 commercial process, because most of the process which were earlier started alkylation process in refining, that was based on the HF, but because of the highly corrosive nature of the HF and the cost involved, now the new refineries or in the refinery also they are shifting, because the environmental constraint, that is also one of the problem. So, they are shifting from HF to solid acid catalyst. ABS Lummus Global, the alkylation process uses a robust zeolite solid acid catalyst formation coupled with a noble reactor processing scheme to yield a high quality alkylate product. The catalyst contain no halogen. Ixon alkylation process, alkylation of the propylene, butenes, pyridines with the isobutane in the presence of sulfuric acid catalyst using auto refrigeration product, a low sensitivity, highly iso, low RBP, high octane gasoline blend stock. But only problem here in case of the use of the sulfuric acid, stachyoins, that process alkylation of the propylene, butylenes and amylines with isobutane using strong sulfuric acid to produce high octane branch chain hydrocarbons using the effluent refrigeration alkylation process, because that is also one of the requirement of the process low temperature. These are the some of the comparison of the parameters: base condition, product RON, product motor octane gasoline, alkylate yield and the total installed. If you compare with the modern sulfuric acid technology, modern hydrofluoric acid and the alkylate, the solid acid catalyst, the product MON, and there is not much difference in the, this is not only the criteria, because when you are using any catalyst, the now the environmental part, corrosion part, these are also coming in the picture, the total cost. So, the product is okay, it is the product in case of the modern hydrofluoric acid is the better MON, base are better than this alkylate yield, base 90% of the base. Total install cost, here it is more than this the sulfuric acid when you are using the catalyst. Total install cost in case of the hydrofluoric acid less. SO yield base less none, equipment maintenance high much lower, that is the one of the major advantage in case of the solid acid catalyst, corrosion problem. So, the equipment maintenance, that is very high in case of the these two sulfuric acid and the hydrofluoric acid catalyst which are using, and that is the reason why we are going for solid acid catalyst. Reliability on the steam factor. So, match FCC are the better sorter. Safety, unit specific safety precautions as well as transport precautions, unit specific is there, because depending upon the unit, safety precaution required that extend thorough output of the refinery, very specific, because here the highly corrosive nature, and safety part, that is no special precaution, that is the one of the again advantage in the case of the solid acid catalyst. Catalyst, here the zeolite catalyst, that is we are using environment significance based steam, that is produced here. Actually, if you compare with the HF and H2SO4, amount of the HF required, if you compare with the H2SO4, that is much less than what we are using in case of the sulfuric acid alkylation. And this was the one of the reason for shifting from sulfuric acid to hydrofluoric acid alkylation. So, in case of the solid acid catalyst, no emission to air, water or ground. This was about the alkylation process, importance of the alkylation process, and as I told you, now the Indian refineries also, as we are not having the alkylation, isomerization already they have it. So, more and more alkylation may come in the future, and with the development of the solid acid catalyst, now it will be easier to go for the alkylation than the problem of the sulfuric acid handling, corrosion or the alkylation of the. So, the isomerization part again just like the alkylation part, isomerization that is also playing very important role now in the refinery as a major conversion process for improvement of the octane number, because the various steams which are getting product from the refinery, they are low octane number product. So, how to improve? So, that is one step in case of the improvement of the octane number, that is the isomerization process. So, petroleum fractions contain significant amounts of normal alkanes, and the isomerization of the alkanes into corresponding branch isomer is one of the important process in case of the petroleum refining. The highly branched paraffins with 7 to 10 carbon atoms would be the best to fulfill the recent requirements of the reformulated gasoline. What are the driving force of the light paraffin isomerization? Because why the units? Earlier units were even in Indian refineries we are not having the isomerization, but many of the now new refineries they are going for the already some of the refineries already they are having the isomerization, and the new refinery definitely they are going to have the isomerization part. So, driving force for the light paraffin isomerization. Recent trend to isomerization could be significant contributor to octane number. Offset octane less from gasoline desulfurization and aromatic reduction, benzene management, increase LPG production, because benzene reduction as per the Euro norms, Euro 4 will have to reduce the benzene content of the gasoline, that is 1% that is recommended, and so the now they are going for the isomer that will be good actually the from the naphtha also, because naphtha isomerization that is also being done. So, that will go to the gasoline pool. So, driving force emphasis on the production of highly branched C5 C7 alkanes isomers from the normal alkanes at low temperature for use in the reformulated gasoline to improve the octane number and the RBP, reed vapor pressure, because the RBP is also included in the standards, and so the RBP that has to be controlled. Isomerate percentage of the gasoline, USA widely implemented during the late phase out period, because that was the period when the requirement how to improve the octane number. So, that was the tetraethylate that was added, but because of the environmental problem lead was phased out. Even in Indian refinery also we no more lead we are using for the tetraethylate for improving the octane number. So, that has been completely phased out all over the world because of the lead pollution. But in case of the US, they have gone for the implementation of the isomerization process in the refinery, and more than 8% of the gasoline they are getting from the isomerate, which you are getting from the isomerization. Western Europe widely implemented during the Euro 4 phase in, because now they are already, even Indian refinery they are ready to provide the Euro 4 fuel, some of the refinery. So, that is how the things, how the importance of, but Indian new units have installed now the isomerization, but still there is lot of scope in going for the further to have the isomerization process in the Indian refineries. Now, let us discuss about the isomerization. The production of the paraffins based high octane gasoline blend stocks such as isomers from isomerization of light and mid cut naphtha might be a key technology for gasoline supply to cope with the future gasoline regulation, because we are producing low octane naphtha, and the use, if it is going to the gasoline, because our requirement maybe, because more and more gas crackers are also coming, so more and more naphtha will be available in the refinery, and so this technology low octane naphtha to high octane naphtha by isomerization process, definitely that will boost the economy of the refining. So, light naphtha and the paraffin isomerization recognizes emerging technology in order to boost octane in the light gasoline fractions. Recent price trends show isomerization could be a significant contributor to octane pool, which will offset the loss from the gasoline desulfurization and the aromatic reduction which is taking place, because now that has become a integral part desulfurization for the removal of the whatever the traces of the sulfur is there, because to meet the requirement of Euro 3 or the Euro 4. Isomerization involves isomerization of the light paraffins, isomerization of the C5 C6 paraffins, isomerization of the N-butane, isomerization of the C5 C6 paraffins allow low octane number paraffins 5 and 6 carbon atoms into higher octane number paraffins. This is the advantage in case of the when you are going for the isomerization of the C5 6. N-pentane, isopentane, N-hexane to 2-methylpentane, 2,2-dimethylbutane, 2,3-dimethylbutane. Isomerization of N-butane to produce isobutene feed for alkylation or a source of isobutene dehydrogenation to manufacture of the MTB. Isomerization catalyst, as I told you, there has been continuous development in the isomerization process also in the refinery. Two types of the isomerization catalyst, zeolite and the chlorinated alumina has been used, and the zeolite catalyst requires higher temperature and provide lower octane boost, while chlorinated alumina result in highest octane. However, it has higher sensitivity to feedstock impurity, requiring strict feed pretreatment to eliminate oxygen, water, sulfur and nitrogen containing compound. Isomerization catalyst, as I told you, it may be zeolite, it may be calamite, chlorinated alumina. Zeolite catalyst require higher temperature and provide lower octane boost. Chlorinated alumina result highest octane, however, it has a higher sensitivity to feed impurities. Isomerization with light naphtha, as I told you, the some of the crude oil which we are having the more paraffinic. So, the what to do of the light naphtha which is more paraffinic and the octane number is low. So, many refineries they have gone for isomerization of the light naphtha to improve the octane number. C5 C6 feed either from state and crude distillation or from the catalytic reforming, that is going for the isomerization process. So, reformate separated in lighter mostly benzene and heavier containing C7 catalytic zeolite or platinum unchlorinated alumina. Operating condition depending upon the type of the catalyst you are having, the temperatures range change, pressure is also, space velocity, hydrogen to hydrocarbon ratio and the product research octane number. Depending upon the type of the catalyst, the parameters, slightly difference in the parameters are there. process, a recycle process, unconverted normal paraffin and any single branch isomers from the double branch isomers, recycling with the distillation, de-isoxyanizer that is added, recycling with the adsorption, adsorption the molecular sieve and paraffins are adsorbed and separated by desorption. So, these are the some of the actually various type of the configuration that may be in case of the isomerization process. As I told you, there has been continuous development in case of the catalyst and the huge amount of the money in refinery that is being invested for improvement of the catalyst, which is either FCC catalyst or the your catalytic reforming catalyst, or it may be isomerization catalyst. So, first generation catalyst, the feeder and the feeder craft reaction, the aluminum chloride exhibit very high activity at low temperature, metal support bifunctional catalyst, essentially platinum alumina sensitivity to poisons are less acute, however require higher temperature. Third generation metal support bifunctional catalyst with increased acidity by halogenation of the alumina support, sensitive to poison and need pre-treatment, corrosion problem, high activity at low temperature. Fourth generation bifunctional zeolite catalyst, very resistant to catalyst poison and feed does not need any pre-treatment. So, this is the actually the changes that has taken place in the catalysts which are being used in case of the isomerization process. In all the catalysts, one of the problem is the presence of the impurities in the feedstock. Now, let us discuss some of the processes which are available in case of the isomerization. UOP butamer process, catalyst platinum chlorinated alumina, operating condition is 180 to 220, pressure 15 to 20 bar, space velocity 2 hour, hydrogen to hydrocarbon ratio 0.222. Another development that has taken place in case of the UP isomerization technology, that is the PENX process. Higher octanes, higher product yields, more than 120 license units were there, PENX and PENX-TM. So, this is the actually the some of the development, and here you see the number of the refinery in other country, they are having the isomerization as integral part. The power isomerization TM UOP introduced this process in 1996 using zeolite chloride sulfate of the zirconium catalyst. It is characterized by lower equipment cost and the multiple catalyst approach. Now, this was about the isomerization part and the importance of the isomerization, the refinery where you can convert the low octane hydrocarbons to high octane hydrocarbons. Now, let us discuss about the polymerization part, because this is also one of the, actually do not be confused with the polymerization which we are using for the manufacture of the polymer. It is mostly the oligomerization part. So, the polymerization process have received considerable interest in the petroleum refining because of the high requirement of the reformulated gasoline and phasing out of the MTB. Because this problem I told you, I have been telling time to time, because MTB that came in a big way as a substitute for the tetraethylate to increase the octane number, and at the same time because the C4 gases, isobutylene that was available from the FCC gases, methanol was there, number of methanol plant came just to supply the methanol to the MTB plant, but there was leakage in MTB tank in US, and so the now there is ban because MTP is highly carcinogenic. So, many countries, developed countries, they have banned the manufacture of the MTP. So, the process may be attractive in two main areas, that the one from the petroleum and the another from the petrochemical part. Upgrading of C2 and C3 temperature 150 to 200 degrees centigrade, pressure 30 to 50 bar, space velocity 0.3 to 0.5. Catalytic cracking for aromatization of ethylene, propylene to olefin gasoline, producing high quality or the middle quality gasoline. Aromatization are getting importance in the refinery in two main areas: upgrading of C2, C3 cuts from catalytic cracking to olefinic gasoline, producing high quality distillates from light olefins. So, this is what happening in most of the aromatization process. So, some of the, let us discuss some of the processes which has been developed in case of the polymerization, the alumination process, industrial process, that is UOP cat-ply process. This process can transform propylene, butene or a mixture of both to high octane gasoline. IFP polynaphtha process to convert C3, C4 and C5 olefins into a gasoline cut. So, then dimersal process converts C2, C3, C4 olefin to gasoline, because in all the cases if you see that we are using C3, C4 and C5 olefin which is available from the FCC gases, and so that can be used for improving the octane number, and that will be also we can utilize these gases which are still not being used in many of the refineries. Mobile olefin to gasoline and distillate technology, light olefin. Here again we are using C3, C4 converted to olefinic product which is hydrogenated to go for diesel oil pool. So, this is the about the alkylation, about the polymerization process, amalgamation process which are using in the refinery. So, in the future, because you see the both all the three processes, they are going to play very important role in improving the octane number, in improving the availability of the high octane gasoline, and at the same time utilization of the some of the gases and the low octane naphtha which is more paraffinic. So, this is the reason why now all the refinery they are getting interest in isomerization, in alkylation process, or in case of the aluminization. Only constant in case of the lesser adaptability in case of the your alkylation process, major constant which was there, that was the acid catalyst, hydrofluoric acid alkylation. But with the coming of the your solid acid catalyst, definitely the problem that is going to be less, at least so far the corrosion, the equipment corrosion problem is there, and that is the reason why now the more and more interest is for the alkylation process. Same thing is in isomerization. So, this was about the, in the next lecture, that is one of the very important part in case of the refinery operation, and with the coming of the various norms, standards which are changing time to time, looking to the environmental condition, desulfation process which is very important in the refinery, and the desulfation of the product, recovery of the sulfur, because it is not only that desulfation you are then it leave in the atmosphere, recovery of the sulfur from the sulfur compound which are removed during the process, it may be Marox process, then the recovery of the sulfur from the class process. So, this has become again integral part of the refinery, because if you want to meet the norms Euro 3, Euro 4, or it may be Bharat 3 or the Euro 4 norm. So, definitely you will have to go for the desulfurization. So, next lecture will be on the desulfurization of the berisphine, and the at the same time, because you are also doing the hydro desulfurization process in the refinery for the removal of the sulfur compound. Already that part we have discussed in the various section of the catalytic cracking, or it may be the hydrocracker, or the in case of the catalytic reform. So, we will be how we are, what are the steam for which the hydro desulfurization is necessary, then what are the desulfurization process, in detail about the Merox and the conventional class process, because there is a lot of improvement, changing in the class process, and at the same time one another source, that is the loss of the sulfur in the wastewater. That is also one of the major problem with the coming of the more and more sour gas, sour crude oil, sorry, not gas.